to the question clone graph. It's a medium level question, and the question says, given a reference of a node in a connected undirected graph, return a deep copy clone of the graph. Each node in the graph contains a value and a list of its neighbors. So the node is defined as this, and let's look at example 1. So 1, 2, 3, 4 is the original graph. We cannot return the same graph, and this looks like a clone. The nodes are new, graph looks the same, so this is what we're supposed to return. And then if you look at the bottom example, it's like not in the correct order, so this is also wrong. And in terms of the input and output, input we get this, and output is this. And it takes in, clone graph takes in a node in node form, and we output a node. So immediately, if this was not in the interview situation, we can do something like import copy, and then we just import a deep copy. We just return a deep copy of the passed in node, right? So we can do like clone node equals copy dot deep copy, and then node, and then we can just return clone node. So what deep copy does, it's like creates a new copy of the node and returns it, which is what this question is asking for. It's a new independent copy, so yeah, this one should be right. And but in terms of this question as an interview question, I don't think we should do this because it defeats the purpose of asking this. So in terms of this question, we can do a DFS, right? And I'm thinking for each, how we can map this. We can have a visited dictionary, and then within our visited dictionary, we can map the original node to its clone so that we make sure we don't go into cycles. Let's see, I can initialize this with the visited dictionary. So self.visited equals an empty dictionary. And then let's do some base case checking. So I would say the first thing I'll check for if it's a valid node that passed in. So if not node, we can just return none. And then let's say if node in self.visited, that means we've already seen this node. We want to return a copy of that, right? So self.visited node. Let me comment here. So self.visited basically consists of the original node mapped to the clone node. And when this is our base case for our DFS recursion, we treat this as our DFS, and then whenever we see that it's already visited, we just return its clone because that's what we want to append to our it'll make more sense when I write everything out. So after these two base case checks, we can go through the neighbors of the original node, right? So for n in node.neighbor, BOR. For n in node.neighbor, it's a list of nodes as its neighbor. What do we want to do here? So we want to do, before that, let's create our clone node. So clone node equals, here's the definition for a node. It takes in a value and neighbors. So for its value, I'm going to pass in the node.val value. And for its neighbors, it's going to be initialized as an empty list. And then since this is created here, let's do self.visited node equals clone node. And then we can move on to its neighbors. So for n in node.neighbor, clone node.neighbor dot append we want to append this node's neighbor to the clone node's neighbor, right? So what can we do? We can do self.clone graph, and we pass in the n as its neighbor, right? So n is each of the node's neighbor. We pass in and set it as the clone node's neighbor as well. So every time we pass in, if it's already invisible, we would just return its clone, but if it's not, we assign it through this process until we assign everything in this graph. So in the end, what we want to return is return the clone node. Node object has no attribute neighbors. It should be neighbors. Yeah, I think this should be the code. Let me know if you have any questions. And oh, and before I forget, the time complexity of this should be the number of nodes plus the number of edges. And in terms of space complexity, the space is based on the height of the tree. So the height of the tree will be the space. And in terms of the visited, the space for the visitor will just be the number of nodes. So it'll be, I think it'll be an average of the number of nodes. Let's just call it ON. And then for the time complexity, it's going to be ON plus M, where N equals the number of nodes and M equals the number of edges. Yeah, so let me know if you have any questions, and I would love to answer them in the comments. And thank you for watching.